Estimation of a physical quantities. Estimation is the process of finding an approximate value of physical quantity using prior knowledge and logical reasoning. Let me explain this with an example. To estimate the height of this building, my drawing is not so good. So take it or consider it as a building which has three floors: ground floor, first floor, second floor. To estimate the height of this building, first count the number of floors. There are three number of floors: ground floor, first floor, second floor. The number of floors. There are three number of floors. Then estimate the height of one floor by imagining how many people standing on each other would reach the ceiling. I'm explaining. To estimate the height of this floor by imagining how many people standing on each other, on the top of each other, would reach the ceiling. Here, two people standing on top of each other reach the ceiling. The height of this person is 6 feet and this person is 5 feet. So total height becomes 6 plus 5, 11 feet. So the height of this building is 11 feet. Then 11, height of this building is 11 plus 11 plus 11, 33. 11 plus 11, 22 plus 11, 33. So this 11 feet is an estimated height of a single floor. So total number of floors are 3. The height of one floor is 11 feet. So the total height of this building comes out 33 feet. This 33 feet is an estimated height of this building. Estimate or estimation. This is estimated value of this physical quantity or the height of this building. Hope you got the point. What is estimation? Estimation is the process of finding an approximate value. Finding an approximate value. The approximate value is 33 feet. Finding an approximate value, this is 33 feet approximate. We find out an approximate value. Find an approximate value of a physical quantity. The height or a length is a physical quantity. Approximate value of a physical quantity using prior knowledge. Prior knowledge means the knowledge you already had. The knowledge you already had. For example, my height is 6 feet. It's a prior knowledge or the knowledge or a previous knowledge. Now prior knowledge means the knowledge you already had and the logical reasoning. Logical reasoning, the height of this person is 6 feet and this person is 5 feet. The total height is 11 feet. Then 11 plus 11 plus 11, total height of the building is 33 feet. It's a logical reasoning. Using prior knowledge is my height is 6 feet. It's a prior knowledge. And this is logical reasoning using prior knowledge and logical reasoning. It's the definition of estimation. Estimation is a process of finding an approximate value of a physical quantity. Length is a physical quantity using prior knowledge and logical reasoning. It is not a random guess, but a reasoned prediction. This is not a guess. This is a reasoned prediction. Now, a question rises, what's the difference between estimation and a guess? Difference between estimation and a guess. A person says, by looking the building without any thinking and logic, he says the height of this building is 50 feet. It's a guess. Without logic and thinking. Someone says the height of this building is 50 feet. So it's a guess. It's not an estimation. And the other person thinks and measures by using their own height. 6 feet, 5 feet, then total 11 feet. It's a thinking and logical. And he says the height of this building is 33 feet. It's an estimation. So that's the difference. As guess is a random answer. Estimation is a logical answer. This is a logical answer, 33 feet. And guess a 50 feet, which is a random answer. Guess is without thinking. Estimation is with thinking. This T shows thinking. This A shows answer. This T shows thinking. Guess for from actual value. Actual value is maybe 34 feet or a 30 feet. It will be the actual value. 33 feet is an estimation or estimated value. Or 50 is a guess. Guess is far from actual value. Estimation is close to the actual value. Guess is for fun and estimation is for problem solving, to solve the problem. So that's a basic difference between guess and estimation. Now, how you got the point? What is estimation? Now, same example is explained here. For example, to estimate the height of a building, one might count the number of floors. The total number of floors are 3. Estimate the height of a single floor. Here we estimated the height of a single floor, which was 11 feet. Then how many people standing on top of each other? How many people standing on top of each other would reach the ceiling? Then multiply the estimated height, and then multiply estimated height, which is 11, with the number of floors to get the estimated height of this building. This gives a rough idea of building height. Now, strategies to improve estimation skill. To improve estimation skill, 4 strategies are discussed here. The number 1, breaking big things into smaller ones. For example, a football ground. To estimate the height of this length of this football ground, divide it or break it into smaller parts as the length of a person, laying down again and again. For example, a person with height 6 feet is laying down again and again. 6 feet laying down here and then here. 6 feet plus 6 feet plus 6 feet, 18 feet. If this is 6 feet, then this will be almost 3 feet. 18 plus 3, the total length of this football ground will be 21 feet. So here we divided big thing into smaller things, smaller parts. The first one is breaking or dividing big things into smaller ones. Breaking this big thing into smaller ones is first estimation skill head. For example, to estimate the size or a length of a football field or football ground, by dividing it into smaller parts. By dividing, here we divide it into smaller parts. By dividing into smaller parts, like the length of a person laying down. Like the length of a person laying down. Its first strategy to improve estimation skill. Now the second one. The second one is aggregating smaller things into a bigger thing. It's opposite to this one. Aggregating means combining. Aggregating means combining. Aggregating means combining smaller things into bigger things. For example, for example, to estimate the thickness of this sheet of paper. To estimate the thickness of this sheet of paper, first I will combine this all the sheets, then I will measure or estimate the thickness of this stack of papers. You can say this bundle, but it's better to say stack of papers. The this stack of papers. Now, thickness of this stack of paper is about 1 centimeter. The thickness of this stack of paper is about 1 centimeter. Now count the number of papers. 1, 2, 3, 4, 5, 5. I already counted. The total number of papers are 80. Then divide by the number of papers by counting, like 1, 2, 2, 3, 4, 5, 6, 7, and the total number of papers are 80. The thickness of this stack of or this bundle of paper is 1 centimeter. Divide by the total number of papers. You will get the thickness of a single sheet of paper. By dividing, you will get 0.0125 centimeter. So the thickness of this single sheet of paper is 0.0125 centimeter, or in millimeter multiply with 10, you will get 0.125 millimeter. So in this way you can get the thickness of this sheet of paper. Here we combined these all of sheets. Aggregating means combining smaller things into a bigger thing. Here we combine this smaller thing into this bigger thing. Aggregating smaller things. These are the smaller things. Sheets are the smaller things. Aggregating means combining smaller things. We combine all these smaller things into a bigger thing. And now this stack of paper is a bigger thing. It's the second strategy. They both are opposite. Here we divided big thing into smaller, or here we combine smaller things to get a bigger thing. They both are opposite to each other. So, for example, to estimate the thickness of a sheet of paper, measure the thickness of stack of paper. This is a stack of paper. Measure the thickness of this stack. Divide by the number of sheets. Divide by the number of sheets. Now the third one. Estimate areas and volumes. Model complex subjects. For example, model complex subjects, a box or a sphere. For example, it's a box. It's a sphere, a ball or a sphere. It's a ball. Model complex objects. Model complex objects are spheres and box. Sphere and box. First, we estimate the length of this box, length, width, or height, or area of this radius of this sphere. Then, by using the formulas, volume of a box is equal to length multiplied by width multiplied by height. Length, height, and width. Length, width, and height. By multiplying length, width, and height, we get the volume of this box. Volume tells us how much fluid or liquid can this box contain. By using this formula, first we will estimate the length, width, and height, and by using this formula, we will get the volume of this box. Then by using another formula, 4 by 3 pi r cube. First we will estimate the radius of this sphere or this ball. Then by putting the values of this radius here, r is the radius, pi is a constant 3.14. So by using this formula, we will get the volume of this sphere or this ball. Now, model complex objects. Model complex objects are spheres and boxes. First, we will estimate the length or radius. Then by using the formulas, this formula for box and this for sphere, we will get the volume of box or sphere. We will estimate the volume. To estimate area or volume. The fourth one, estimate the mass from volume and density. Here we have a formula, density, rho is equal to mass per unit volume. Rho represents the density. Density is equal to mass per unit volume. By rearranging, the volume will multiply with density. Volume will multiply by density, then mass is equal to volume multiplied by density. Volume multiply with density. Volume multiply with density will give the mass. Now, to estimate the mass from volume and density, to estimate the mass from volume and density, first estimate the volume. By using these formulas, we can estimate the volume. First estimate the volume, multiply it with the density. Volume multiply it with the density to get the mass. These are 4 strategies to improve estimation skills. A short question, difference between guess and estimation. That's the answer of this question. Now another question rises. Why we estimate instead of measuring with tools? Why we estimated the height of this building instead of measuring with tool or with inchy tape? We estimate when we don't have tool, when we don't have inchy tape. We estimate when we need a quick answer. I'm repeating. Why we estimate, it's a question. Why we estimate instead of measuring? We estimate when we don't have tools or when we need a quick answer. We estimate. Hope you got the point. Create estimation table of some physical quantities. Create estimation table. It is the estimation table of some physical quantities. Estimation in length, estimation in mass, estimation in time. Another important short question: why do we estimate instead of measuring directly with instruments? Please note down this short question. Why do we estimate instead of measuring directly with instruments? Instruments can be a stopwatch, a scale, a measuring tape. These are the instruments, a weight balance, etc. So question is, why do we estimate instead of measuring directly with these instruments? So the answer of this question is, we estimate when we don't have a suitable instruments, or when we need a quick answer. We estimate when we don't have a suitable instruments or when we need a quick answer. Now, these are the suitable instruments. No estimation in length, diameter of proton. What is diameter? What is diameter? Diameter is the distance. Diameter is the distance from one point of the circle to the other point. From this point to this point, it's the center. Diameter is the length or distance from one point to the other point, passing through the center of the circle or sphere. Passing through the center of circle or sphere. The diameter is the length. No, diameter of this circle, we can measure it directly with the instrument. The scale is instrument. So we can measure the diameter of this circle, which is about 14 centimeter. The diameter of this circle is 14 centimeter. We measured by using this instrument or scale. Now, diameter of a proton. We can't measure the diameter of proton directly using the instruments, because proton is very small particle. We can't see even with a microscope. I'm repeating, proton is very small or extremely small particle. We can't see even with a microscope. So because of its tiny size, we can't measure its diameter directly using the instruments. We can measure the diameter of this circle using this instrument, but we can't measure the diameter of this proton using this instrument directly, because proton is too small. Even we can't see with a microscope. So scientists estimate it. So scientists estimate its diameter by using indirect method. It's a direct method, but scientists estimate it using indirect method, like high energy particle scattering experiments. Scientists estimate its diameter using indirect method, such as high energy particle scattering experiments. Number two, the diameter of hydrogen atom. Just like proton, the atom is also extremely small. We can't see even with a microscope. So we don't have any instrument to measure its diameter directly. So scientists estimated its diameter. The estimated diameter of the hydrogen atom is 10 power minus 10 meter, and the estimated diameter of the proton is 10 power minus 15 meter. Now number three, diameter of earth. Earth is an extremely large object. Because of its huge size, we can't measure its diameter using the instruments. Even by using this measuring tape, we can't measure the diameter of the earth, diameter of the earth. Earth, the diameter of the earth. Why we can't measure? Because of its huge size. So scientists scientists estimate it by using indirect method. It's a direct method. So again, scientists use an indirect method, such as satellite observation and calculation. Scientists estimated the diameter of the Earth, which is about 10 power 7 meters. Number 4, 1 light year. 1 light year is the distance that light covers in 1 year. 1 light year is the distance that light covers or light travels in 1 year. For example, in our space, there is very large distances. The distance between stars, the distance between Earth and the Sun, the distance between the Moon and the Earth. We can't measure these huge distances using these instruments. So scientists using these instruments directly. So scientists estimate it by using indirect method. By using indirect method, such as speed of light or time, by by multiplying speed with time, speed of light with time, we can get the distance traveled by the light. So 1 light year is the distance that light travels in 1 year. The estimated distance is 10 power 16 meters. Now estimation in mass, then estimation in time. Mass of proton, same, it's a diameter of proton, diameter is the distance. Now mass of a proton, again, proton is extremely small particle. We don't have any instrument to measure its mass directly. So scientists estimate it using indirect methods. The estimated mass of the proton is 10 power minus 27 kg. Similarly, the mass of proton, the estimated mass of electron is 10 power minus 30 kg. Mass of mosquito, a mosquito is a very small and light insect. A mosquito is a very small and light insect. So we don't have any instrument to measure its mass directly. So scientists estimate it by using indirect methods. And the estimated mass of mosquito is about 10 power minus 5 kg. Similarly, the estimated mass of the earth is about 10 power 25 kg. Now, estimation in time. Time for one heartbeat. The time for one heartbeat is 10, its estimated time is about 10 power 0 seconds or 1 second. Any number raised to the power 0 is 1. For example, 5 power 0 is equal to 1. 5 power is equal to 1, 0 is equal to 1. 128 power 0 is equal to 1. Any number, for example, another number 78 power 0 is equal to 1. Any number raised to the power 0 is equal to 1. So 10 power raised to 0 is equal to 1. So it's 1 second. The time of for one heartbeat is approximately equal to 1 second. Estimated time of 1 year is about 10 power 7 seconds. Estimated age of the earth is about 10 power 17 seconds. And estimated age of the universe is about 10 power 18 seconds. Now, difference between qualitative and quantitative observations. Qualitative observations and quantitative observations. First, qualitative observations. Qualitative observation describes qualities and quantitative observation describes quantities. Qualities and quantities. In quantities, for example, the table is 2 meter long. 2 is the number and 2 meters is the measurement. Quant- Quantities using numbers and measurements. 2 is the number and 2 meter is the measurements. And quality, the sky is blue. No number, no measurements. Here in quantities we have numbers and measurements. In qualities we don't have any number. The sky is blue, no number. The flower smells sweet, no number. The water feels hot, no number. The object has 5 kg. 5 is the number, 5 kg is the measurements. Number and measurements. The stopwatch shows 15 seconds. 15 is the number and 15 second is a measurement. It's number and measurement. So quantitative observation describes quantities using numbers and measurements. It is based on instruments and measuring tools. It is based on instruments. To measure the length, we need an instrument, measuring tape. To measure the length of the table, we need this instrument. But here we don't need any instrument. It is based on the instruments and measuring tools. This is the example. 2 meter, 5 kg of 15 seconds. Now, qualitative observation describes qualities without using numbers. Without using numbers, it is based on our five senses: sight, smell, touch, taste, hearing. So, qualities depend on our five senses. The sky is blue, the flower smells sweet, the water feels hot. It's another short question: difference between qualitative and quantitative observations. First page, first year physics, first chapter, and first page. You will see qualitative and quantitative observation. Now, example 1.1. In this example, estimate the energy required for an adult man to walk up through stairs from ground floor to the first floor. In this example, we have to find the energy. Energy from ground floor to the first floor. Find energy from ground floor to the first floor. from ground floor to the first floor. So the vertical energy, we have to find the vertical energy, and the vertical energy is known as potential energy. So we have to find the potential energy from ground floor to the first floor. So in this estimation topic, if data is not given, so we have to estimate it. For example, for an adult, adult mean a fully grown person. Adult mean a fully grown person, normally over the age of 18. So we need the mass of adult, the height between the floors. So you can estimate, normally the height between the floors is 10 feet or 3 meters. So estimation required. We have to estimate the mass of the adult and height between the floors. G is constant, 9.8 or normally 10. Now the mass of adult normally we can estimate as 70 kg. The height or a distance between ground floor and the first floor is normally 10 feet or in meters 3 meters. So the mass of adult we estimated 70 kg. The distance between the floors is estimated as 3 meter. So by putting these values in this formula, mass 70 kg, G is 9.8 or 10, taken as 10. The height is 3 meters. So after multiplication, we will get the potential energy of 2100 joule. It's the required energy of this exercise. Assignment 1.1. Estimate that how many floating point operations. FLOPs stand for floating point operations. FL stand for floating point. OP stand for operation. S for plural, for more than one operations. So S shows more than one operation or for plural. So how estimate that how many floating point operations can a supercomputer perform or do in one day? Time for single floating point operating in a supercomputer is 10 power minus 17 seconds. To solve this assignment, the given data is 10 power minus 17 seconds for single floating point operation. FLOP, not S, because it's a single floating point operation. If time for a single mean one floating point, time for one floating point is 10 power minus 17 seconds, and in one day, time in one day there are 24 hours. Each hour has 60 minutes. Each minute has 60 seconds. So time in one day after multiplication is 86,400 seconds. So the given data. Now solution. Solution, floating point operations in 1 second. In 1 second, 1 divided by 10 power minus 17. It's the time for single operation. Floating point operation. For one operation, 10 power minus 17 second is required. Means in 1 second 10 power plus 17 operations can be performed. I'm repeating, in 10 power minus 17 second, one floating point operation can be performed. So in 1 second 10 power plus 17 operations can be performed. So floating point operations in 1 second, 1 divided by 10 power minus 17. So 10 power, after rearranging, this negative will be converted into positive. So 10 power plus 17 floating point operations per second. FLOPs in 1 day. In 1 day, there are 86,400 seconds. And in 1 second, 10 power 17 operations can be performed. So after multiplication, we can calculate the floating point operations in 1 day. 8.64 multiplied by 10 power 21 floating point operations in 1 day. That's all.